As we have completed the algorithm behind binary searching, let's try to write the Java implementation for it. For that, inside the searching package, I'm going to create a new class by the name binary searching. Okay, I'll simply add the main method and I'll simply finish. We just close all these files. Here we will be writing the binary search implementation. Now let's try to write a function public static int. Let's name the function as binary search, and it will basically take integer array of arr, and it will also take a value in the variable value. So now our aim is to search if the value is available inside that array. If so, we will have to return that specific value. But something that you have to remember is in this ARR, all the values are arranged in the ascending order. Based on that, we are trying to perform this binary search. If the values are arranged in the descending order, we need to change and modify the end and min values according to that. But anyway, when we go to that point, I will explain it anyway. But remember that the values are sorted in ascending order. Now what I will do, I'll simply define a int min. This will be the starting index, or you can go ahead and name variables as like start and end. I mean, people follow different formats. So here I will be following min and max for representing the minimum index and maximum index in the array that we are trying to process. So the minimum index will always be 0 and the maximum index will be array.length minus 1. So the max is array.length minus 1. Okay. Now we will also define one variable called mid. In the beginning we will initialize it with -1. Okay. Later on we will use this mid variable to hold the middle index that we are going to calculate. So now what we will do, we will simply run a loop as long as min is less than or equal to max. That means that these two values have not been overlapped, which basically indicates that we have searched on both sides, so the value is not available. So as long as min is less than or equal to max, what I will do, I'll simply calculate mid equal to max plus min divided by 2. Okay, this will basically give us the middle index. So if the value at this middle index is same as the value that user has passed, we will simply return this mid index. Okay, otherwise, that means else if the value in the middle could be larger than the value that we have been given or smaller than the value that we have been given, right? Because the array is sorted in ascending order. So if at all, if the array value that we have at mid, if it is greater than the value that user has passed, that means the mid value is greater than the value that user has passed. That means the value could be on the left side. That means the max, we need to update it to max equal to mid minus 1. Okay, otherwise if this is not the case, that means whatever the middle value is smaller than the value that user has passed. That means whatever the value that user wants to search is on the right side. That means the min, we will update it to else min equal to mid plus 1. Okay, so this is how we write the while loop. So what technically we are doing, we are calculating the mid based on the min and max. Once the middle index is found, we are comparing the value at that middle index. If it is matching with the value that user has passed, where that itself is like a value, so we are returning it. Otherwise, if the value at the middle index is greater than the value that user has passed, that means that user wants to search the value on the left side. So we will decrement it by assigning mid minus 1 to max. Otherwise, the value is on the right side, so we will update the min index to mid plus 1 so that we can search in the remaining range. If this while loop is executed successfully, that means that if at all, if we don't return anything inside this if logic, that means that whatever the value that user wants to search is not available. So in that case, we'll simply return -1. So in the beginning, I mentioned that this array is sorted in the ascending order, right? If at all, if the array is sorted in descending order, all you have to do is you just interchange this max to line number 18, this min logic to 16. So if you just interchange these two values, in the case if the array has been sorted in the descending order, this binary search will work in that case too. Okay, but however, I'm mentioning once again, this logic honors if the array is sorted in the ascending order. Okay, now let's go and call this function and validate the results. Let's say integer array that I want to use for searching ARR is 1 2 3 4 5 6. Okay, these are the array. Because I need to pass the sorted array, I created an ascending order arranged elements. Now let's say the value that I want to search is, let's say 3. Now let's try to call binary search. Let's pass array and the value. In the end, this function will return the available index, right? So let's take that value inside the variable index. Let's just print it so that we can validate it. Okay, now let's just run it. Okay, if you observe, it gave the index 2. So if you observe here, index 0 has value 1, index 1 has 2, index 2 has 3. Okay, similarly, let's say if I want to search the value 6, also it perfectly works fine. Okay, 6 is available at index 5. Similarly, let's say I want to search the value 16, which is not available in the array. In that case, our program should return -1. Okay, now I will leave modification of the code in terms of when we give the descending order sorted array. You can just go ahead and modify these lines and you can just call that function and validate the result for yourself. Okay, this is how we actually implement the binary searching algorithm using Java. Okay.